Alright everybody, we're going to start some notes here on 3-6, talking about parallel lines, and we're very familiar with these from our algebra days, and so we know what they look like, and we know something about their slopes, and so this should be something that's fairly familiar. However, we're going to, of course, talk about some new geometry terms that go along with them. So the first one is corresponding. And the best way I can demonstrate corresponding for you is to kind of think about road intersections. So you might recognize these two intersections. And so if we look here at Walton Boulevard and Squirrel, you probably know that there's a McDonald's right here on this corner. And if you go down here to Adams Road in Walton, okay, you know that up here is the village. Okay, so we know some stuff here in relation to one another. We also know that there's a Coolio right here, and Starbucks is on that corner. And so when we talk about intersections, if you're good at north, south, east, and west, this would be the northeast corner. And angles that are corresponding are in the same location. So when we talk about north, south, east, and west, the northeast corner and the northeast corner are corresponding. They're in the same location. All right, north of Walton Boulevard, and then to the right or to the east of their corresponding roads. So if you could take that idea, okay, if we kind of continued Walton Boulevard all the way across there, this is kind of the picture we're going to have. Two lines. So here are north-south roads, two lines that are being intersected by one other line, and that creates a situation where we have a bunch of linear pairs, a bunch of vertical angles, and also now a bunch of corresponding angles. So we can kind of keep this little road intersection idea in mind as we look at these now in a more generic form, okay, with just lines J and K and line G intersecting it. Now this one's kind of turned on its side from the one I just drew on the map, but nonetheless, two lines, okay, J and K, and then G here is the one that's intersecting each of those. All right. So we know that lines that are parallel, we know that their slopes are equal, and so they have the same tilt, and therefore they never run into each other. The transversal is kind of a hard one to write a definition for. It's kind of lengthy. It's actually easier than the definition, but the transversal is the line that intersects two other lines. And when we have that situation, like I just drew on the map with Coolio and the Village Mall, okay, those are in the same location. So when we talk about corresponding angles now, we're talking about angles that are in the same location relative to the two given lines, which in this case are J and K, and they're on the same side of the transversal. So in this case, if you look at number 1 now on your paper, which line there is the transversal based on what we just talked about. Okay, so the one that's cutting through the other two is G. So G in our case is the transversal. And then the corresponding angles, let me just exit out of this for a minute and do one other thing for you to demonstrate what we mean by corresponding. So here's our two intersections, and so if I were to just grab this line here and start sliding it, if I slid it down here so that it matched up with the other line, then the angles that ended up on top of each other, so in this case 1 would correspond with angle 5. Okay, angles that ended up right on top of each other are in the same location. To the left of the transversal and above our other line. So if I put it back now, okay, angle 1 and angle 5 are both above and to the left. They're in the same location. So that's another quick example of what we would mean by the angles that are corresponding. So go ahead and see if you can answer the other two now. So angle 1, we already said corresponds with angle 5. And then angle 6 would go with angle 2. Angle 4 would go with 8. And of course, that means the one we didn't do would be 3 and 7, but that's not really on your paper. So that's corresponding. That's what we mean by corresponding angles, things that are in the same location. Then the postulate that goes with this, and from here on out, now that we've had our justification sheet, anything with this little smiley face by it, okay, means it needs to go on your justification sheet, on your cheat sheet. And remember, you're just writing the title, so you're just writing what's in blue here. And I would encourage you to kind of write it just like I did there, so abbreviate a little bit. But parallel lines implies corresponding angles. And what we mean by that is if we know that our two lines are parallel, our two given lines, and then they're cut by a transversal, the corresponding angles are going to be equal, okay, if those two lines are parallel. And notice it's an if and only if, so that means it's true backwards as well. But this is one where we have to pay attention to which order we're using it in. So you really want to put this on your cheat sheet this way, okay, the way I have it typed up here, and then you want to take the converse of it as well. So if I start with corresponding angles as the antecedent, and then I use that to conclude that the lines are parallel, that's also a possibility. So you want to put it on your cheat sheet that way as well. So two things you want to add here to your cheat sheet, okay? Because it's going to be important that we pay attention to what order we use this in. Alright, so if angle 4 is 78 and 1 and 4 are vertical, then that 78, here, angle 1 would have to be equal to that because of the vertical angle theorem. And then we can jump up to the other ones that are corresponding. And angle 1, we already said, corresponds with angle 5. So angle 5 would also be 78. And then it's vertical with 8. And so we know it has to be equal to angle 8 as well. And then if we jump back down here, angle 4 is corresponding with angle 8. So 4 of those are 78 degrees. And then all the rest of them have to be a linear pair. So if I put angle 1 or angle 4 together with angle 3 over here, we get 180 degrees. And so 180 minus our 78 will give us the rest of them. So angle, we should have a measure of from all of these. Talking about numbers. So the measure of then all the rest of them, 2, 3, 6, and 7, all have to be 102 degrees. All right, let's kind of skip over number 5. I think we'll get the hang of this if we just look at number 6 together. All right, anytime you run across a question like this where there really aren't any numbers given to you, you're just given equations that you have to All right, when we run across an example here where we're just given a bunch of angles and expressions that we need to put in some sort of relationship, the first thing to do is ask yourself, the ones I'm given, how are angles 5 and 1. So if we just kind of focus on those two, because those are the ones we're given some information about, how are those guys related? Well, they're corresponding. So 1 and 5 are corresponding angles. And because we're also told that these lines are parallel, J and K, our little postulate here says that these things have to be equal. So we can take the expressions that were given, 5 times x plus 1 and 3x plus 31, and we can say those things have to be equal. Right? So if they were vertical angles, same thing. You'd be able to say they're equal. If they were a linear pair, then we'd want to add them up and set them equal to 180. So it's important that you look at your angles that you're given and then figure out what the relationship is between them. What kind of angles are they in relation to one another? All right, so distribute. Here's the algebra part. And then get your x's on the same side. So combine like terms. And then take numbers the other way. Subtract 5 to both sides. So that's gone, and that's gone. And we have 2x equals 26. And then divide, so of course x equals 13. Now, the question is not just what is x equal to, but to find these other two angles. So again, go back to our drawing, and we want to say we know angle 1 and we know angle 5. We could plug in and find what those angle measures are, so that might be helpful, is to go ahead and plug back in. So let's take our 13 back up here and figure out what the measure of angle 5 is. So 5 times 14. And that would be 70, right? Yeah. So then going back to our picture, angle 5, how does it relate to 2 or 6? Well, here's angle 6. And so angle 5 and angle 6 are a linear pair. And so the measure of angle 6 has to be 180 minus 70. Okay, so always going back to our picture and asking ourselves, how are angles 5 and 6 related? And then once we know that one, we can throw 2 in the mix. And 2 is down here. And then there are a number of ways to go about this one. Okay, 2 and 6 are corresponding, so they have to be equal. You also know angle 1 and angle 5 are the same, so angle 1 is 70. So however you want to go about mentally looking through that one, but angle 2 and angle 6 are the same because they're corresponding angles, and so angle 2 would also be 110. All right, kind of a lot to that problem, so feel free to backtrack if you need to and take another look at that. All right, one more thing that needs to go on your cheat sheet, so give your brain a little bit of a chance to recover from that last example. That was kind of a tough one. And so transitivity we've heard about before a couple different times, and so the transitivity of parallelism, so here's making up my own words here, but transitivity is a relation between three things. Remember, we talked about the middleman. So here are our three lines, L, N, and NL. And so just think about what this means. We have lines M and N, and we know they are parallel to each other. And I think I mentioned yesterday that we put these little an extra set of arrows on our parallel lines like that to just indicate that they're parallel. And then if we throw line L in the mix over here as well, and if we know that N and L are parallel to each other, then it seems to make sense that we can jump right from M to L and say that those are parallel also. All right, and that's exactly what we talked about with transitivity. We kind of drop out the middleman, which in this case is N. Right, kind of go back to what you can see here. Here's our middleman, and we can sort of just get rid of him, just like right there. So M and L have to be parallel. So number 7 is sort of an extension of that on your paper. Of course, there are more than 3, but we could do transitivity a couple different times. Okay, so R to S, drop out S, and then Y and E. We can drop out Y as well and jump right from R is parallel to E, still by transitivity of parallelism. So that's number 7. All right, here's some more practice with justifying. Okay, so you see the directions there. Justify each conclusion, which means you're going to pick something from your cheat sheet, your justification sheet. That's what that direction always means. Okay, so you're going to fill in the blank with something like definition of this or that theorem. And so look at a picture. And this is the one we've been working on so hard. That's, I know, a difficult one to kind of grasp here. But you look at the picture, kind of forget about everything else that's on the picture, and just focus on angle 4 and angle 1. So one strategy would be to use colors and trace over it or redraw it, so you're just focused on that. And when you look at that, what your eye has to go to is that you've formed a straight line. And so by looking at the picture, I can see that it's a linear pair. You can see those two angles are a linear pair, and I'm concluding that they are supplementary. Oops, done that wrong. Okay, and that little sequence, starting with a linear pair, figuring out that they're supplementary, is the linear pair theorem. So number 9. We're going to keep working on that one, and we'll get it. Okay. All right, number 10, angle 5, measure of angle 5 is equal to the measure of angle 8. So go to your picture and look at 5 and 8. And what kind of angles are those? How are they related to one another? They are vertical. They share a vertex, across a vertex from each other. And so if I look at them and I can see they're vertical, and then I conclude that they're equal, that's by the vertical angle theorem. The theorem is what tells us they're actually equal. The definition tells us what they look like. I could look at 5 and 8 and look at that picture, and I could conclude that they are vertical angles. This asks us to conclude that they're equal. So I know that seems like a technicality. It's kind of the nature of what we're dealing with here is technicalities. All right, I look at the picture, and I'm told that line P and line T are parallel, and that we then want to focus on angles 5 and 3. And so here's 5 and 3. And now how are 5 and 3 related? Well, they are in the same location. And we just learned this one. And this is the one where I said the order matters. So what's given? The if is that the lines are parallel. So parallel lines is what you want to write down first. And what are we concluding? We're concluding these angles are equal, and they are corresponding angles. So given that the lines are parallel, if the lines are parallel, then the angles are equal, corresponding angles. All right, 12 should look very similar to that. So if you take a look at that one, the only difference here, we focus on angle 4 and 7. And now those two angles are also corresponding. So again, we're talking about a pair of corresponding angles. But this time we're starting with the angles. So up here we ended with angles. Down here we want to start with angles. So this is why I encourage you to put it on your cheat sheet both ways, because if you flip the order around, you're really not using it to prove what you're out to prove. You're out to prove that the lines are parallel, and so we want our if and our then to be lined up, okay, what we're trying to prove. All right, the last little bit here is about slope, and solving an equation and finding the slope, and looking at the picture and finding the slopes. And so I'm going to leave that to you, and we will cover that in class if you have trouble, but that should take you to a little flashback of some algebra days. All right, and I will we'll be working on this in class, so you do not need to do this right now, but you have the maze as well that you could be working on. And section 7, he should come to class done, and then I will get the next video posted as soon as possible.